Hey, hello, do you still know who I am? Let's finally conclude this series. I've found a way that is a little bit easier to build the roof. It's still a little bit annoying, but you know, I'm happy to finally conclude this series. I've made this little block, which is going to be my roof geometry for now, so we can see what we are doing. And I will add another mesh primitive, grid, which is the same node we used to build the walls. This time though, we will use it to plug up this hole at the top here. So I will duplicate a point instance from here, and this time set to object, and just sample this little cube that I made and plug it into the grid and plug this into the join geometry. And now somewhere a grid should have appeared. Down here a grid appeared. First of all, I will get myself another one of these group input nodes, which are, you know, just passing these values into the node system here, and I will duplicate it. Oh, that didn't work. Move it over there, and we will do the same shenanigans with the walls. We will need these values. I'm going to plug this one into X and this one into Y. And as you might remember, if I have a depth of like 5 meters and I add 1 and make 6 vertices out of that, then we get a nice and evenly distributed grid. So we will do the same thing again. Utilities, math, set to add, that's already fine. Add 1 to these values. Plug it in here. And I should mention that only works if your cubes are 1 meter by 1 meter. You might have to plug in another value here if you have less even size. So now we have a grid. It didn't quite work, but I won't worry about this for now. Let's instead work on the issue that this roof isn't really at the right position. It's a little bit low for a roof, so we might just add another geometry transform here and move it up. So obviously we have to move it some value on the z-axis, and this value is going to be our height, because whenever we change this height, our roof has to get higher or less high. We will use a vector combine x, y, z, so we get access to the individual axis, and under translation I'm just going to plug in the height from this group input into the z-axis. Here we go. No, didn't quite work. We have to probably add or subtract a value here. So how about we subtract 1? Not quite. 1.5. That's a little unusual. I think the problem is that I didn't... Yeah, as you can see, that's my fault. I'm sorry, I apologize. My base mesh here is floating relative to its origin. Now the origin is nice at the bottom of the thing, and now it did work. So I actually have to subtract an even number, which is 1. Let's correct the positions of the other axes. So I could just manually move them around right here, but that still doesn't change the fact that the roof is too wide. So we have to yet again subtract a value from here. So I'm just going to feed in another math node in front of here and set it to subtract. So now we should have the right dimensions, and the only thing left to do now is to just manually move it to the right spot. And it will probably be a very even, nice number, either a full number or like a 0.5, like in this case. 1.5, that's very good. Now the last thing I would check is if I scale the building up, if that kind of shifts the roof over because we have like a mistake in our thought process, but no, everything looks fine. And essentially we do have a roof now. This is not all that satisfying now though, because I yet again want to have another model on the corners than I want to have in the middle. And I also want to have borders that look different. So instead of just 2 models like we had before with the corner and the flat wall, we now need 3 models. So let me quickly model these models. Great sentence. Yeah, that's not perfect, but it will do for a visual representation. I think what I would like to do is I would like to move my point instance after the transform, because that's just a little bit more convenient, because I want to use some point separation yet again. Point separate, and if you remember, we declared those corners, but if I type in corners here, like I did with the walls, for example, you might notice that nothing happened. And the reason for this is that all these values that we calculated for the corners and the walls don't actually exist in this new node tree that we made here. All those calculations were calculated on the basis of these grids here at the front, and this is like, you can imagine, like a separate arm of the node tree that is completely disconnected from the rest. So what I will do is I'll move it over here to the beginning of this entire situation, and I want to add it into this entire thing so it benefits from the same calculations we do here, and we don't have to do all that much all over again. So I'm going to sever this connection, and I will just, why not plug it into the join geometry here. That's a problem. We are shifting this model upwards right here. If you remember, we did this so that the origin point of our buildings is at the bottom and not in the middle. So I will disconnect it again and put in another join geometry after this transform. And now if I plug it in, hopefully that's better. I'm wondering, why is it too tall right now? Oh yeah, first of all, we don't need this corner. Oh, and we also have to remove this point instance here, of course. So now it all should look relatively fine. We have a roof. The models are incorrect right now, so I kind of want to separate the entirety of the roof from the rest of our model. So I will put in another point separate node right here at the very end of our entire tree, before we start separating off all these corners and gaps and whatnot. I'm just going to put in a point separate node here and name it roof. And now the only thing left to do in order to separate it out, I have to declare that all those points that we created down here, that we just created, are called roof. And the way I'm going to do it is I'm going to use an attribute fill node, and everything that goes into this geometry will now be affected by this attribute fill node. So I'm going to create this roof variable that we just used back there, put it to a value of 1, which, you know, in binary terms is like a yes, all of these things are a roof. Yeah, I can change it to integer if I'd like, but this really doesn't matter all that much. And now everything that comes out of this bottom output from the roof separator should be the roof. And I know it now looks like before, with a little difference that we can now access all the variables that we declared before. So if I use a point separate node, and this one conveniently already has written corners into it, and plug it in before here, you can see that we actually get the corners. Great. So, but instead of the corners, I think I want to start with the walls. Those are a little bit more important to me. So we do not have a variable that is that includes all the walls. I don't think so. I think we only have this top wall, bottom wall situation, but that's already quite useful. So I'm just going to create a new variable, and I'm going to, well, now let's think of a new name. How about edge? This variable is now supposed to store all of these edges that go around here. And now I'm going to get myself another attribute math node here. I hope it's not confusing to you that I'm just duplicating it. It's just faster than navigating to it, because I never know where they are. You know, I'm just duplicating the ones that are already here. So the result is going to be edge, which is the new variable that we want to have here. Oh, that's looking interesting, isn't it? Let's quickly clear these inputs here. And we want to have the top, left, right, and bottom wall in here. So let's start with top wall, and, which means add, and the bottom wall. These together shall be written into edge. And as you can see, the top and the bottom wall have now disappeared because they are now routed to geometry 2. Now, to this edge value that we just made, we now also want to add the right wall, and we want to add the left wall. It's not the most convenient way to do it visually, I know, but that's how we add all the walls that we had into this new group called edge. So now we can separate out the edge. Now we can separate out the corners. Next thing we should do is now put models there. Why not? Duplicate the point instance node, and I'm going to use this mesh here in the middle I created, which should be the straight corner. Well, this is the edge. I'm going to put it here, add it in. That's looking good. And the corners are those 4 blocks here. And as you can see, I have to separate them out from geometry 2 because, well, if I would split off something from geometry 1, well, the corners aren't included in this branch. They are down here in this branch. So another point separate node in here, and corners, which is the value that we already have conveniently. Duplicate this point instance node, and this time it should be that. Hey, come on. That model. Wonderful. Add it into the join geometry, connect it to geometry 2, and now, even though it looks messy, we can see, let me go into the top view for, now that's looking terrible. Let's stay in the 3D view. Yeah, we have straight corner pieces here, we have this L piece in the corner, and we have the empty pieces in the middle. Perfect. The meshes are distributed. Now the only thing left to do is we have to rotate it. And yeah, this is going to be a little bit dirty, and it seems a little bit stupid, but that's the only way that I can think of right now that is fast. And, you know, little side note here, I know that you might think, especially if you're a programmer and you're into this entire perfectionism and performance idea, all these nodes are relatively fast. If this entire project is slow, it's because we have probably hundreds of thousands of polys, because it's it's a very high density model, obviously. If we add 1 or 2 too many nodes and we are not working all that clean in the geometry node setup, that's really just a very small influence on the performance. So don't worry about making a mess, really. So because what we're going to do, we're going to separate out the top wall, and we're going to use a join geometry, plug it in between here, and join both geometries together. Well, now nothing has changed until the point where we go to point, rotate, plug it into the bottom input in between here, and now we can rotate this wall. Wonderful. And now, well, you've guessed it, we have to do the same thing 4 times. Well, 3 times, because this wall is already aligned correctly, obviously. So 2 duplications, left wall, right wall. So the left wall has to be rotated 270 degrees, which would be the equivalent to minus 90 degrees, whatever you prefer. And this one's probably going to be rotated 90 degrees. Probably it's not capitalized, probably it's with a small r, right? Wonderful. So, as you can see, we're almost done. Everything is rotated correctly apart from 3 corners, because even though the corners are declared correctly, the rotation is wrong. And yeah, we have to build more nodes. Who would have guessed it? I'm sorry, it's annoying. There are a lot of nodes, but what can you do, right? So, the way we will do this is precisely like we did it before here. Instead of right wall, however, I can't just type in corners here because that would move all 4 corners. So I have to separate out the individual corners. So corner 1 is going to be the first one that we will rotate. And since corner 1 doesn't exist yet, we obviously have to declare it. And I'm going to rotate it now at some weird angle, like 45 degrees, so I can instantly see what geometry I am actually affecting. Well, what point I'm actually affecting. So let's add in a new attribute math node here. And we set it to multiply, which is the same thing we did the last time to get the corners in the first place. So I'm going to multiply the top wall and the right wall, for example, and I'm going to write this into that corner 1 value, which in the logic of this tree doesn't exist yet, even though it's written in here. But now it exists, and we can immediately see, due to our weird rotation that we chose, that is obviously the corner that's affected, and we have to rotate it 180 degrees apparently. And who would have guessed, now we do the same thing multiple times again. So, duplication. Now you see why I was hesitant to do this thing, because it's just annoying. We don't really learn anything new compared to the last parts, because those are all things that we've already done. But, you know, at some point you just gotta, how do you say, close your eyes and go through with it. Bottom wall and right wall would lead to this one here. 90 degrees? Nope. 270 degrees? Yes, that was correct. And now this is the top wall, I think, right? So this should be top left, because we've already rotated top right. So one last time and we're done. I think I don't even actually have to rename those values every time, because it doesn't matter if they're overwritten. Let's test it out in a minute. Let's just call them all, I don't know, just for testing purposes. G, 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 G. Yeah, you know what? If you consider this clean, you know, it's not faster or better, but you could have just written the same value in all of these nodes. It doesn't matter, since, you know, once we've rotated it, we don't really need to come back here and do anything else with them, so we can just overwrite this value for the next. But you know what? I'm just going to keep it with the names, because well, who knows? Maybe at some point I do want to specifically reference corner 2 or whatever, you know. So, but more importantly, we are now done. Hey, congratulations. I applaud you if you did it by hand up until here, even though the Gumroad project is only $1. You know, you could have saved yourself a lot of time. I don't blame you though, because I don't really profit from those Gumroad sales. Perhaps I should have put it as like $3 or something, because I only get 39 cents per sale if it's over PayPal. Because Elon Musk, this super rich Corona profiteer, is taking a cut away from my money that is larger than 50%. Those are great news, aren't it? That's it essentially. And I mean, all the other things that you could do now are things we have done already. You could, instead of putting in an object, you can put a collection here. For example, if I want to have some roof details, I'm just going to duplicate this thing like a couple times and put it all into one new collection, which is going to be roof center. And this should be this upper point instance. Let's put in roof center here. Wonderful. And now, since it randomly selects one of these, I can just, I don't know, take one of them and move them up. And you get, what is that? AC units, knock yourself out. just start playing around with it. And I mean, look at this. I mean, those are the most basic models that anyone could ever model. You can't really pretend that this takes any amount of skill to do, but the end result is still relatively impressive in my opinion. If you would texture them in a nice way, you know, and put I mean, this is definitely an object you can put in the background in the scene. And if you now take the extra time and model some nicer parts here, you got a very professional looking building, I think. If any one of you happen to have 2 rows on one of the sides instead of one, perhaps it's a rounding error, which you can fix quite easily by using this value, by changing this add value on the bottom wall detection, or whatever wall is buggy for you. And maybe just try decreasing it by 0.1 or maybe increasing it, and that usually fixes the problem for me. I'm unfortunate, I encountered it at some point yesterday when I pre-built this project just to test it out, but now I can't replicate it. That's too bad. Or maybe that's good, I don't know. Maybe it's good that I'm unable to get an error here. So in terms of the project here, I will maybe do one last video at some point, just referencing some tips or interesting suggestions from the comments. If we have questions, perhaps we will put it in video form, maybe not, we will see. What I could offer you right now, we could do a little course on how I would model all these individual little parts to make them look good, to make them fit into the building. However, that wouldn't be a geometry nodes tutorial anymore, just a modeling and texturing tutorial essentially. If you're interested in that, let me know. If not, hey, that's fine as well. We will have other fun content that you can look forward to, I hope. Other than that, thank you so much for watching. Yeah, consider checking out Patreon and join the zeros of followers that I have there. And hey, I don't know how to end this video.